All right, any figure now. How do I find the area of any figure? All right, doesn't matter how many sides it has or what it is. How do I find the area of any figure? Just before we start though, all these figures today I'm going to ask you to find the area of will be, and tomorrow, this is a 2-day topic, regular. Let's just review real quick. Regular, if a polygon is regular, it has two qualities that we went over before. All sides are congruent and all angles are congruent. All right, so just want to remember that definition if you're told a polygon is regular, all the sides and all the angles. I also want to introduce you to a new piece of a polygon that you only thought existed in a circle, but they also exist in polygons. From the center to a vertice. What do you think I call that? If it was in the circle, what would you call it? That would be a what in a circle? That's what I thought too. If this was a circle and I drew this line in here, you call it a? And that's exactly what it is in a polygon. This is a radius. Polygons can have radii too. And what did you know about all radii in the same circle from last unit? 4. What do we know about all the radii? Okay, and so they're all congruent in a polygon too. Meaning, what type of triangles are formed now when I draw in all the radii? What do I call those triangles? 6? Isosceles. Yep, so the isosceles triangles are formed. So I am not, Spence, go ahead, sorry.
Why is it not equilateral if all the sides are congruent?
Because I don't know if the radii and the sides are all equal. That's why. Yes, all the sides, because I would have to do this now.
Yeah.
Okay. Good point. But it could be. It could be. Depending on the figure, it could be. All right, but not all the time. So I'm not going to give you guys a new formula. All right, you're going to use a formula you already know and use it to find the area. Notice we wrote isosceles triangles. You know the area formula for a triangle? Area formula for a triangle. 4? Okay, yep. So here's how we're going to find the area of any regular polygon. Because look, I always form triangles when I draw in all the radii. We're going to take that area of a triangle, 1/2 BH, and we're going to multiply the number of triangles formed. That's all we're going to do. I don't have a fancy formula. Oh, you got to remember this formula if it's a hexagon. Oh, if it's an octagon, remember this form. No. How many triangles it's formed times 1/2 BH. That's how we're doing this. You ready to go? Try one out? All right, good talk, as usual. All right, I got a regular hexagon now. Regular hexagon. Express your answer in simplest radical form and a decimal rounded to the nearest 10. All right, so it's a hexagon. So now I go to my area. 1/2 base times height times how many triangles would be formed. We don't have to do this. I don't want to do this every time. How many triangles would be formed if I drew in all the radii in a hexagon? 5? 6. And you guys are starting to see however many sides this thing has, that's how many triangles it has. So I'm going to multiply my answer by 6. All right, I drew the one triangle out. Let's do 1/2 base times height on that triangle. We're going to find the area of one of the triangles and multiply it by 6. Let's see if we can do this. So area 1/2. Hey, you're welcome. I already gave you the 3, which is the base of the triangle. We got to work on what's the height. And then I'll multiply everything by 6. All right, so I got to find this height. How long is this height? Going back, remember all the angles were congruent, right? All the angles were congruent. So take a look. I need your help first. Can I find angle ABC? Help me find angle ABC to get going. Now look, don't do this because it's just going to be a mess, but if I drew in all the radii again, all 6 of these angles inside are going to be congruent. Can you find me what one of them is? Right? All those angles are going to be congruent. I just want one of them though. How can you find just one of the angles? What's your process here? 7?
Doing like n minus.
Well, no, that's for these here. Almost there. What do you think they all add to?
3.
Yeah. And then there's 6 of them, so divide by 6. So one of those angles is going to be 60 degrees. Oh, it gets better. What do you think that height, and I'm not going to go into why here, but that whole angle is 60. What do you think that height's doing to it? And you're going to be correct. Take a wild guess what the height is doing to that 60-degree angle. And this happens all the time. 8, what do you think's happening, Sophia? Yeah, the height bisects that angle. So now that 60 gets turned into 30. Oh, what do we got going on here, kids? 30, 60, 90. Yeah. So we got to go back to our rules. And Sophia, remember Sophia just said, hey, that angle gets bisected, so does the side. Okay, the height bisects the angle and the side, and that's important because that 3 is going to get broken up into what? 8 again. Sophia, you're on the bisecting train. 1.5. Good work. So each side is 1.5. The height bisects the angle and the side. All right, keep talking with me here. I got a lot of people today to get to. Charlie, 13. The 1.5 is across from what angle? 30, that makes it the shorter leg. Where's the height across from? Okay, so can somebody remember my rule? How do you find the longer leg in a 30, 60, 90? What do I need to do? 1, Anna, you remember shorter leg?
Times radical 3.
You got it. So what is my height now? Shorter leg, which we know already, times radical 3. What's my height going to be? Just put them together. 9, what's my height?
1.5.
There you go. All right, so get ready to be dealing with 30, 60. Ooh, maybe a 45, 45 coming up. Is everyone all right how we got there? You find the main angle by doing 360 divided by the number of sides. Cut the height, cuts it in half. Excuse me. All right. Reminder, how do I do simplest radical form? Everyone see the radical in that problem? It stays radical 3. Now you multiply everything else. Okay, simplest radical form, put the radical 3 in there and then multiply everything else for me. $12 when you're ready.
13.5 radical 3.
You got it. 13.5 radical 3. And let's keep going with the directions. And as a decimal rounded to the nearest 10. So what is 13.5 radical 3 rounded to the nearest 10? Because I'd like both answers just to keep practicing your rounding. When you're ready there, 4. What do you got back there, stud?
13.4.
Look at you. There we go. How's everyone all right? We got more. We have more. Don't worry. And it's a 2-day topic. All right. Let's keep talking. Area of a square. We're going to do this 2 different ways. We're going to do it using our triangle method that we just talked about. And then, hey, what if I don't want to do the triangle method? I just want to use the area of a square. We'll talk about that. All right. So using triangles, 1/2 BH, how many triangles would be formed if I drew in all radii in this square? 2, 8, how many triangles would be formed?
4.
4 of them. So I'm going to multiply this by 4. All right, go ahead, draw in one of those triangles right now. I didn't do that like I did the previous problem. Draw in one of your triangles. So draw in at least another radii. And hey, can we, because we're going to get a lot of markings on the diagram, can we remember that the radii is 7? All right, that 7 belongs to the radii, nothing else. All right, what angle did you guys just form? Before I draw in the height. What angle did we just form here?
90.
Oh, how do you know it's not? How do you know it's 90? How do we get there?
Because
If I drew in all of them, right? They add up to 360, and now instead of dividing by 6 like the last problem, I divide by 4. So that is a 90-degree angle. Good job, Spence. All right, everyone, draw on your height now. Draw on your height. What did I just make? 45, 45, 90, right? If that angle was a 90-degree angle up top, I just bisected it. And now I made a 45, 45, 90. So I need help finding the base and the height now. I need help finding the base and the height. Okay, if it helps, I'll draw if it helps you too, right? 45, 45, that was 7. How do you find the hypotenuse in a 30, 69? Sorry, 45, 45, 90 again. What was the rule? 3. Remember the rule, Spence? Leg times. Yep. And when we find it, remember, these are both congruent to each other. When we find it, right? They're both congruent. All right, what is the hypotenuse in this diagram? I already know it. 11, yep. 1, Anna, what's the hypotenuse like?
7.
Okay, everyone ready? 7 equals my leg times radical 2. I need your help. How do you get the x by itself? I'm only doing this because you guys are above average for me here. 5, how do I get that x by itself?
divide by radical 2.
Yep. Anybody remember anything from doing this? There's a big no-no up on the board right now. Dig deep, come on. Anybody remember? What doesn't look right up here? You remember, Elion?
Can't have the radical 2.
Say it again, go ahead, you're correct.
Can't have the radical 2 on the bottom.
Can't have any radical in the bottom, right? Forget it has a 2 in it, any radical. You remember bonus here? Remember how to get rid of it?
Times.
Multiply top and bottom by the radical. Yep, so let's get that out of there, everyone. All right, so let's finish this. What do I get on the bottom? And radical 2 times itself? 2, yep, I heard it, 2. And then up top, I just put the 7 and the radical 2 together. Whew! All right, ready? We already know the height is 7 radical 2 over 2. What about the base, huh? What about the base? Remember what we said, the height, Sophia, going back, the height bisects the angle and
The base.
the side too, right? The base, that, so if that's 7 radical 2 over 2, that's 7 radical 2 over 2. Anybody know how long the whole thing's going to be now? Combine those. That's all I'm asking you to do here is to combine those two fractions. They have the same denominators, right? So keep it the same. And then what happens when you add 7 radical 2 to another 7 radical 2? How many do you have total? If I add 7 radical 2 and 7 radical 2. Anna?
14 radical 4.
Just keep the radical the same. Radical 2. Good. Yep. And now go to your calcs and let's punch it all in and you'll see this ends up being a whole number. Heavy duty math here. $98. No? Using your fraction templates? If not, hopefully you are. Should be getting 98, no? 1/2, fraction template, 14 radical 2 over 2, another fraction template, 7 radical 2 over 2. All right, look. Oh, go ahead, Ellie. Go ahead.
24.5.
Okay, you did 1/2, right?
Yeah.
Oh, what did we forget to do? I didn't bring it down. That's for that triangle. This is on me. How many of them are in the square, right? Times. Yeah, so go ahead and multiply your answer by 4. Yeah, that's on me too. That's on me. All right, I get it. 99% of you, this is probably not your cup of tea doing it this way. Especially this, this is some advanced stuff over here. It's not the only way to do it. This figure's a what? What is this figure? And you know what the area formula of a square is. It's length times width. So if you wanted to use that instead of breaking it up into triangles, you could. And maybe this is going to be a little easier for you. Let's see. So I am not going to do the triangle method here. This was 7 originally. Can you help me find a side of the square instead? Let's approach it a little differently because I get it. Most of you probably don't like this at all, and I don't blame you. All right, it's still a square. Can I do length times width? Well, how can I find a side here? Everything you know about a square. Anything you want me to add to my diagram. Forget about triangles. And don't remember anything what we just did above. This is just a square. How can I find the side if I know that piece right there is 7? Anything you want me to add to this? Nate, let's go. Do you want me? Where do you want? Because I could add it a couple different places. You just want me to extend it?
No.
Or okay, so you want me to go here now, right? All right. So that's 7. And what did I just form there? What can I do to find the side? Don't forget about what we did above. Pythag. Everyone agree? Pythag? 7 squared plus 7 squared equals c squared. Good job, guys. Good job. 49 plus 49 equals c squared. What's that? 98. C squared equals 98. So one side is the square root of 98. You could break that down if you want, but it's not going to be needed. And it's a square, so what's any other side? Square root of 98. So when I go length times width, it's going to be the square root of 98 times square root of 98. And magic pops out. 98. Geez, why don't you just do that from the beginning? Here's why I'm not. Because this last problem with the hexagon, you have to do the triangle method. Because there's no area formula for a hexagon. You have to. So that's why I need to show that. All right. But when you get to a figure that you already know a formula for, I don't care what you do, triangle method or use the formula for it. It's just things like a hexagon. And tomorrow I'm going to go into an octagon and a pentagon. We got to do the triangle method. All right. We have no, so it's good to know how to do it. Questions here? All right. Last one for today. Triangle. Equilateral triangle. The fact that it's equilateral is huge. All right, using the triangle method again. Let's use the triangle method. So 1/2 base times height times what now? How many triangles would I form in this one? 1 again, Anna. How many triangles would I end up forming if I drew in all 3 radii? 3. Yep. All right, draw in one of those triangles for me. Draw in the other radii. And I'm going to ask somebody, what is that angle that you just formed? Okay, that angle right there. What is that angle you just formed? It used to be 60 in the hexagon, 90 in the square. Well, this one, it's going to be, what's that angle that we just formed there? 12? Remember, if I drew in the other radii here, Rachel, all 3 of these would be congruent. And they had add to 360, right? 120, right? 360 divided by 3. That angle's 120. Draw in your height right now. And remember, what's your height doing to that 120? 9, what's that height doing to the 120? Bisecting it. So does everyone see why I'm going to put a 60-degree angle up here? So that's 60. The height forms a right angle. Up, I'm dealing with the 30, 60, 90 now. Okay? Can you find the other sides now? What does the 4 represent? Shorter, longer, the hypotenuse. Shorter, longer, hypotenuse. 2, Nate, shorter, longer, hypotenuse on the 4. Hypotenuse, right? So if you know the hypotenuse, what was the rule for the hypotenuse in a 30, 60, 90? 7, shorter leg times? 2. Good catch. So 4 equals 2x. I think you guys can find the shorter leg now. Eight, what's the shorter leg? 2, so that's my height. There's 2. There's the height of that triangle. And how about the longer leg? What's the longer leg here? Use your rules. What's my longer leg going to be? 10? Shorter leg times? Okay, so go ahead. What's my longer leg now? 2 radical 3. Good. And hey, since that side gets bisected, if that's 2 radical 3, other side is 2 radical 3. All right, help me fill out my formula now. Area equals 1/2. What's the base length of that full triangle there? 2 radical 3 and 2 radical 3. Put them together. 10 again, Iris. How long's the whole one? Perfect. What's the height of one of those smaller triangles? 10 again. Iris, you're on fire. Just take it over here. 2. And then, unlike the last problem, I got to multiply that by 3. Leave your answer in simplest radical form for me. That's it. So leave that radical 3 in your answer, everybody. Leave the radical 3 in your answer. So if you left it in your answer, what do we got there? 6 times 4 is 24, 12 radical 3. When you multiply 1/2 times 4 times 2 times 3. Questions? All right. Maybe this method isn't for you. All right. Maybe it's not for you. So let me redraw this beast here that I started you with. What did I give you? The radius is 4. You just use 1/2 base times height. That's it. You don't cut it into 3 triangles. You're just doing one. Ready? 1/2 base times height instead. Maybe that's what you're doing. Okay? Maybe that's what you're doing. So how could I get in the base and the height here? Equilateral triangle, remember. Anybody want to add anything onto it? I already know that piece is 4 there. Equilateral. Equilateral. All sides and all angles are equal, right? Can anybody help me find this angle? All the angles are equal. What's this angle going to be here? If it's equilateral. 60, right? $60 over here, right? 60 over here. Cuts it in half, 30. And this is going to run into what we just did over here. Right? Take a quick look here, and I'm going to go through this a little bit quicker than the last one. If that's 4, I'm not going to go over all the work again. Across from the 30 is 2, right? How long is this piece here? From the center up, how long is that piece? We got it.
4.
Why? Because it's a what? What do I call that? From here up. It's a radius, isn't it?
Yeah.
So all the radiuses are the same, so that's got to be 4. So I already know that's 6 for your height. And now do your 30, 60, 90 rules. That's 2. That'll be 2 radical 3, 2 radical 3. And that's where I got my 4 radical 3. So if you wanted to do it this way, your 4 radical 3 would still be there, but now my height is going to be 6. So you got to do what's best for you. All right, got to do what's best for you, whether you just use the plane formula or you break it up into triangles. And you guys notice 6 times 4, 24, half of 24, 12. So you're still going to get 12 radical 3 either way. All right, we got plenty of time here for you guys to start practicing here on the next couple pages. Or actually out of the textbook, right? 1, 2, 3, 4, 5. Leave all your answers in simplest radical form. Here we go. You decide what you want to do. If it's a hexagon, though, you have to break it up into triangles.